Students, this is Miss Green, and previous to this section you learned a little bit about what we're calling the unit circle, and now we're going to take the trig functions that we've studied and see how we can relate them in that unit circle. A little bit of review. I want to know which quadrant these particular angles lie in. And the angles are given in radians, and you remember that you have 4 quadrants. 1, 2, 3, 4. And when you go all the way around in a full circle, 360 degrees, it's the same thing as going around 2 pi. So 360 is the same thing as 2 pi. So think about where this would be pi here, this would be pi over 2, and this would be 3 pi over 2, or 1.5 pi's. Think about that and see if you can answer it, and then I'll come back with the answer. These answers. So the first one, we know that pi over 6, which if you had is 30 degrees. If you weren't sure, you could always multiply. You could always set up your proportions and figure out how to solve for like pi over 6 radians. Well, 360 degrees is 2 pi radians, right? So you could do a little canceling out there, and 360 divided by 12 would give you 30 degrees. So that's one way to do it. If you're not sure, if you can't remember, just set up your proportion. You can also do 180 over pi. It doesn't matter. All right, so pi over 6 is 30 degrees, and since this is 45 here, 90 degrees, sorry. 30 would be about here somewhere. So that would be about pi over 6. So it'd be quadrant 1. And then the second one, 5 pi over 3. You could do a couple things. You could transfer 5 pi into degrees, if that's 5 pi over 3 in degrees, if that's easier for you. Again, 180 degrees is 1 pi. And then you could multiply that out and see what you get. 3 goes in there 60 times, so that would be 300 degrees. And we know that this is 90, 90, 90, 270, right? This is 270 and this is 360, so it would be in the 4th quadrant. That's another way to... Also, you could just divide 5 divided by 3 and compare it to 3 divided by 2, and it would be a little bigger. So whichever way you choose, that's what you want to be able to do, though. Figure out which quadrants they're in. Maybe even figure out the equivalent in degrees. That would be another challenge for you. To help us with these trig functions, we're going to look at these special triangles. And we're going to look at triangle 45, 45, 90. And we know we have certain ratios. So if this was 6 and this was 6, this would be 6 square root of 2. Remember, it's an isosceles triangle, so these sides are always congruent because these angles are congruent. And the hypotenuse is always square root of 2 times whatever the side length is. Now, in a unit circle, we know that this is 1. The hypotenuse is 1. So if you think about this as a 45, 45, if this is 1, and what did we say previously? Let's say this is x. That's the same thing as square root of 2 times x, right? We've already determined that to be true. So if 1 in a unit circle is the square root of 2 times x, divide both sides by square root of 2, and you get x equal to 1 over the square root of 2. And for reasons, we still do it occasionally, for very odd reasons, we don't want the denominator to have a radical in it. And so we can simplify that to be square root of 2 over Square root of 2 times square root of 2 is 2. So that's something we're going to talk about. And I mean, you could have a note sheet and just remember this, or you can figure it out every time. Or if you do it enough, you do end up just remembering it. But if this is 1, and this is a 45/45, then this is square root of 2 over 2, and this is square root of 2 over 2 for a 45/45 in the unit circle. Now we also use our special triangles with the 30, 60, 90. So these are degrees, 30, 60, 90 degrees. And we know that the short leg, so this is the short leg, is if that's x, the hypotenuse is 2 times the short leg. And then this is square root of 3, this would be long leg, square root of 3 times the short leg. That's something we know is true. So in the unit circle, the hypotenuse is always 1, and you just have to remember which one you're looking at. So this is 60 degrees, which, do you remember? It's pi over 3. So it's 1/3 of 180, so that's 60 degrees. Then this one would be 30. And here's my right triangle. Okay, so if this is 1, then I know that this is half. This side length right here is half. This is pointing to this. Maybe I should get a different color here. Let's get a blue. So the side length right here is 1/2 of 1, which is just 1/2. And then this right here, from the previous one, if you remember, look up there, yeah. I take the short leg and multiply it by square root of 3. So this is square root of 3 times 1/2, which is just divided by 2. That's for that one. So again, you could memorize the 30, 60 triangle sides with a hypotenuse of 1. You could just memorize it. Or you could figure it out by knowing what a 30, 60, 90 triangle of any hypotenuse length, what the proportions are. So that's up to you. You decide what works best for you. Now, when we look at something like this 2/3 pi, is that angle right there, and we want to figure out the sine and cosine of that angle, we're going to use the unit circle to do that. And here's where the things start to get a little interesting. It's kind of fun. If you think about a unit circle, the radius is always 1. So this right here would be 1 unit, whatever unit we're using. Now, you might be able to see from this graph that I could actually make a triangle here. And here's what's interesting. Here's when the things get a little interesting. If I make a right triangle here, I can't really make the right triangle over here. I can see that this right here is 180 minus whatever this is, or 1 pi minus whatever this is. So 1 pi minus 2 pi over 3, 2/3 of a pi. 1 pi minus 2/3 of a pi gives me 1/3 of a pi. It makes me hungry thinking about pies. Okay, so we call this the reference triangle and this the reference angle. So we'll call this pi over 3. Now, if I was just doing regular old sine and cosine, I would call this opposite side and this adjacent side, right? So I would do, let's see, the cosine of pi over 3 would be the adjacent over the hypotenuse. Well, I don't know the adjacent, so I'll just call it A, and the hypotenuse is 1. Well, that's kind of interesting. The cosine of pi over 3 is A divided by 1. So the cosine is whatever the length is of that triangle. Do you remember what pi over 3 was? Let's go back. Pi over 3, we went back here, was the same thing as my 60-degree triangle. And in the unit circle, this length right here is 1/2. Whoops. So this side right here is 1/2. So this would be 1/2. The cosine of pi over 3 is 1/2. Now, the sine of pi over 3 is the opposite over the hypotenuse, which is just 1. So it's just whatever my opposite side length is. Let's do another color here. Let's do orange, yellowy. So that length right there is the long leg of the 30, 60, 90 triangle. Well, I remember that. That's the same thing as square root of 3 over 2. So you see why these come in really handy, right? Remembering those triangles. You might want to just keep a scrap sheet of paper, a little note card or something, and have those on there so you would have it with you at all times when you're doing your math anyway. Now what's interesting here, I think, this point right here is the length of, well, the length, and then we have to add in the direction too. But it's the length of the short leg of the reference triangle. So the x value right here and the y value is a, which we said a was the cosine of pi over 3. So the x value is associated with the cosine of pi over 3, and the y value is associated with the sine of pi over 3 in this case. This is true. Now the only thing you have to look at here is which quadrant it's in, because depending on the quadrant, your sign, your plus or minus sign will be a little different. So we said cosine was half, but I'm in the second quadrant, so the cosine is actually negative 1/2. Really not liking this yellow, but I'll change it here. And then the sine is positive, so the sine is square root of 3 over 2. And again, you do kind of get to the point where you've done this enough and you end up figuring it out. But for now, we're trying to discover new things and finding some things out about. So this was the 2 pi over 3, what we started with, but then we used the reference angle of the pi over 3. And then we put the sign in, plus or minus, depending upon which quadrant it is in. Let's see if I can go to the next slide here. There we go. So now I'm going to look at this 45-degree angle, actually the negative 45. And you remember that negative means I go clockwise. So negative angles are clockwise, which makes our brain work a little harder sometimes. But that's a negative 45 degrees. And this is in the unit circle. We can actually use the unit circle to find the sine and cosine of a negative 45-degree angle. Well, you remember once again that this will be my reference triangle this time. And you remember that whatever length this is the same. Our hypotenuse is 1. If I go back to my 45-45 triangle, that's not a very good one, is it? To use your imagination on this one. There, that's a little better. Okay, so 45, 45. The sides are the same, and we don't know what they are just yet. And then this is 1. But we do know that this is also the square root of 2 times x. So x ends up being 1 over the square root of 2. And we don't like that denominator with the square root in it, so we're going to change it. And we're going to end up with the square root of 2 over 2. So x is the square root of 2 over 2. Now, since the coordinate here for the x and the y value here, see, this x is actually the same thing as y, right? So I would write square root of 2 over 2, square root of 2 over 2. Which one's positive? x is positive, but the y is negative. So they're the same absolute value. And remember, this is the cosine of my angle. So this is the cosine of negative 45 degrees. And then this would always be the sine of 45 degrees, because that's in a unit circle. Shows up like that. Kind of interesting. All right, let's try another one. I want you to try these on your own, and I'm suggesting find out where the 4/3 pi is on the unit circle. Then basically you're finding the x and y, or the short leg and the long leg of the reference triangle that goes in there, and then put your plus or minus signs depending upon which quadrant it's in. So I'll give you some time to do that. Be patient with yourself. Go look at your notes, give yourself some time, and see what you come up with. Drawing those little circles, you might want to print off some graph paper if you don't have a unit circle graph paper. That helps a lot. So I looked at the 4/3 pi, and the first thing I did was subtract pi from it. So I knew that would give me 1/3 pi, and I remember 1/3 pi, or 1/3 of 180 is 60 degrees. So I knew this was my 60, 30, 90 degree triangle here. So my reference triangle is right here. So that's 60 degrees. It's a little hard to see from my drawing. And then I remembered from what I did before that the x value is the short leg right here, and that's 1/2. And then the long leg, the y value, is the square root of 3/2. And since it's in this quadrant right here, which is the third quadrant, they're both negative. Cosine is always the first, the x value, and sine is the y value, coordinate. I did the same thing with the 45 triangle, and you can look at that and see if you agree with what I did. Now we can use some of the identities. These are just things that are true. Sine squared plus cosine squared equals 1. And if you think about the right triangle that I form, and the hypotenuse is 1, and we said this was cosine, right? Whatever the x value is, the cosine. It's the absolute value of cosine of theta. And this is the absolute value of sine of theta, the distance. And a squared plus b squared equals c squared. So that's where that comes from. So now, if we want to find the sine of theta, if we know the cosine of theta is negative 3/5, and the angle measure, so what is the sine of theta? And the angle measures in quadrant 3. So it's telling us it's in quadrant 3, so we know both values will be negative. Well, we can just use this identity right here and say sine squared of theta. Theta is just the angle I don't know. Plus cosine squared of theta equals 1. Well, what do you know? You know cosine of theta is negative 3/5. Doesn't matter if I use positive or negative here, because once I square it, you know what? The negative goes away. So the sine squared of theta would be 1 minus 9/25. And I know how much we love fractions, but this is the same thing as 25/25, right? And so the sine squared of theta is 16/25. Now, just like when you had x squared equals 16/25, you can take the square root of both sides, and you would get the sine of theta, not just theta, the sine of theta would be 4/5, because you take the square root of both of those. And that's all it wanted us to do, was what is the sine of theta? Well, it's 4/5. Oh, wait a minute, it's in quadrant 3. So since it's in quadrant 3, I kind of like to use this a different color to remind me that it has to be negative, because it's in quadrant 3. So pay real close attention to those values. Right, I'm going to have you try these, and it tells you which quadrant it is by the positive and negative. You try these, and when we get back, we'll see if we agree on the values. the math here. I just had those unit circles just to kind of give me a reference to what's positive and negative. You don't have to use that. But this one would come up to be the sine of theta would be square root of 2 over 2 because it ends up being, if you remember, it's a 45-45 triangle. So the sides are the same. And then the cosine of this particular angle ends up being a positive 0.6. Now I'm going to look at tangents. So you've done the sine and the cosine. You remember the sine of the unit circle would be the y and the cosine would be the x value coordinate. So if I know sine and cosine, I can find the tangent. So it says, what is the tangent of negative 5 pi over 6? Again, I would draw the unit circle to try to figure out what kind of triangle it is. And I thought I had one on here. Let me see if it shows up if I push this. There it goes, like magic. Okay, so negative 5 pi over 6. Remember that's going this way. Negative goes clockwise. So that means this little thing right here is pi over 6, which that ends up being 30 degrees. So now I have my 30, 60, 90 triangle. So that lets me know that the y is 0.5. The absolute value of it is 0.5. And then the x value, that would be, do you remember what that is? You take the short leg and multiply it by the square root of 3. So it'd be the square root of 3. Maybe you want to put 1/2 there. Square root of 3 over 2. Whoops. Square root of 3 over 2. Yeah, I think I might change that to a 1/2 because look what it makes it easier when you start messing with fractions. Because now I can just dividing by fractions the same thing as multiplying by the reciprocal. So that's the same thing as 1/2 times 2 over square root 3. Then these two cancel out and I get 1 square root 3. Well, I don't like that on the bottom. So, oops, I don't know what that does. So I end up with square root of 3 over 3. And that's the tangent. Now you can figure out the sine by realizing that both the cosine and the sine are negative. And if it helps you to do it here, that's fine too. It doesn't really matter where you do it. But if they're both negative, then the end result would be negative divided by negative is a positive. So the tangent is a square root of 3 over 3, and it's positive. Now, what is the tangent of 3 pi? We found that, I'm not actually sure. You can divide by -1. I was thinking you can't divide by 0. But anyway, 0 divided by anything is 0. So let's make sure we got that going here. All right. So the tangent of this particular 3 pi is 0. Now I want you to try these, and you can use this to help you. This one might take a little more work if you remember how to do those. This one ends up kind of interesting. I used the blue circle here for negative 3/2, so you end up at the pi over 2 right here, which is 90 degrees. And that point is actually 0, 1, so the cosine is 0 and the sine is 1. So the tangent is sine divided by cosine, 1 divided by 0, which is undefined. The math police do not like it when you try dividing by 0. It breaks the law. Now, 675, I drew it around once, that would be 360, and then I go around 315, which would take me here. Once I'm here, I realize I'm only 45 degrees back to 360 again, and I did a little math over here. And since it's a 45-45 triangle, the sides are going to be the same. So even if you didn't get the square root of 2 over 2, you know they're going to be the same, so you're dividing by itself. So there's another equal sign here. Whoops. Sine of 45 equals this, and the cosine equals that. Now, in this case, the sign would be negative because that's in the fourth quadrant there. So -1 would be your answer for that. And here's some nice summary for you for this section. We didn't do the reciprocal functions. We didn't do those, so don't worry about those. But this does give you a nice summary for what we're doing here. Okay, I know this is a lot in one day. It's a lot. You might take a couple minutes to go over some things, try them again, go through your Math Excel, ask some questions. We are towards the end of the school year here, and we're just working hard. It's like running a marathon. This is the last leg, so you're doing good. Keep it up.